Well, here we are getting suited up, ready to go fly. I didn't look all the way there. Carl waving at everybody, thumbs up. He's ready to go. Leroy's ready to go. This was really a gentlemanly flight for me. I'm used to getting up at 2 in the morning and getting suited up. The red team got to sleep in till 7:30 or something. We had virtually no sleep shift at all. We were ready to go, walking out in daylight instead of the middle of the night with lights shining. Bringing up the end here, the guys that like Cleveland an awful lot.
Certainly for any first-time pilot, ascent is the highlight of an aviation career. And here we see the three main engines igniting, and from the inside you can see the vibration that we feel as the main engines light, but before liftoff. Now we'll go back to the outside and you'll see the solid rocket boosters ignite, the explosive bolts fire, and we are on our way. There's no doubt at this point in time that we're headed out of town. I think the next shot will be from the inside of the vehicle, and you'll get another shot of when the SRBs ignite, and then once again liftoff. Immediately after this, the roll program starts. We can see the horizon out the side windows twisting beneath us, and as we point the nose gently down toward the horizon, we head out over the Atlantic Ocean to the east. Certainly first stage is a tremendous acceleration, tremendous vibration. It's an exciting ride. At about right now, I was able to sneak a peek out my side window, and already I was able to see the sky darken to a deep purple. During a summer afternoon launch in Florida, high humidity, so you can see the shock waves, the condensation from the shock waves as we go supersonic coming off the nose of the vehicle and off the external tank. In a moment, you're going to see an outstanding view of something we've never really seen before, and that's a condensation shock right there. Just shortly after that, we have the solid rocket boosters complete their 2 minutes of thrusting, and they separate from the vehicle. You can see the large plume of smoke, and this is what it looked like from the inside. You can see the separation motors fire across the windscreen and the orange plume come across the windows. From that point in time, for the remainder of the flight, those windows were covered with a residue that kind of hampered our photography efforts from those front windows. This is the thumbs up. There's Bob giving an enthusiastic thumbs up shortly after solid rocket booster ignition. And we are continuing on up to MECO, that's 17,500 miles per hour. And just saw Carl recognize the fact that we went through 50 nautical miles in altitude. Here is MECO, and you can see how we move forward in our seats as the 3 times our normal weight is relaxed off of us. Here's a view looking out toward the external tank as it is separated from the vehicle. Here's another picture, I believe taken by Don or Leroy, and that's true speed. We're down at, we're coasting uphill from 70 miles altitude at this point, and you can see how fast the world is going by.
Once we got on orbit, we opened up the payload bay doors, activated the lab, and went to work for 14 days of exciting microgravity experiments. Here I am headed back through the tunnel to see how the guys are doing back there on a turnover between shifts. Most of the time we had 2 people back in the lab, but twice a day they traded notes to find out how the lab was operating and what was going on. The laboratory is just, it's a fantastic piece of equipment, and it certainly increases the amount of working volume that you have.
This was my first flight with a space lab, and besides the fact that it's the world's finest microgravity laboratory, it was a unique place to work because it's much bigger than just the inside of the flight deck and the mid-deck. You can see all 4 of us are back here. That's because we're in the middle of a handover. We're all handing over the notes from the previous shift to the next shift so we could keep up continuous ops. We worked steady in there 2 shifts a day for the 14 days or so that we had the lab operating. We had about 80 experiments, several of which were life sciences. 2 of the life sciences were looking at us as the subjects. Chiaki's in the lower body negative pressure device, which was managed by folks right here at JSC, and I was the operator on this particular experiment, and then later it'd be my turn to get into the lower body negative pressure device. We also flew a suite of experiments by a Canadian team from Vancouver, Spinal Changes in Microgravity, which was looking at what happens to your body and particularly what happens to your spinal column. It's well known that we get a little bit taller in space, and of course that means you're pulling on the spinal cord.
This was another experiment that was looking at changes in our ability to perform cognitive and motor tasks. It was called PAWS, the Performance Assessment Workstation. And it's somewhat like a video game, but it wasn't fun.
This is the biorack facility. This has flown on previous missions, and it's got a centrifuge there to spin some samples up to create a 1G condition. We had other samples in 0G, and we had many plant and small animal experiments in each of these small containers that you see me inserting in there. So we had a good 1G and 0G comparison between these two in space.
Here I'm doing the looking at the microscope. We have a lot of biotechnological experiment like cell culture and protein crystal growth and free flow electrophoresis.
Well, the fruit flies that you see here, I watched them every day over the course of the flight, and the ones on the left are microgravity. As Don mentioned, we had the ability to have some in 0G and some in 1G. Tell you what, the ones in 0G quickly learned not to try and fly.
Here comes the German experiment using very special facility. It's a slow rotating facility. It's a jellyfish to find out its gravitational sense. So we have a lot of life science experiment. We had more than 82 experiments. And this is the goldfish. And some of the goldfish doesn't have inner ear, the organ. So this experiment to find out how fish react to the microgravity and also how fish orient themselves. And here there's other different kind of fish called medaka, killfish. And the researchers are pretty much excited to find out their mating behavior and also the egg development. And you can see small baby fishes. These eggs are laid on Earth and hatched on space. And this is, and they are developed very well. And also, this is a newt experiment, and we have such a very special facility called Aquatic Animal Holding Facility, and made by Japanese Space Agency. And this is a newt, and these are the baby newt, and researchers are pretty much interested in the inner ear organ, which usually necessary for the Earth condition. So we have such a very lot of life science experiment on board.
The other half of our experiments focus on material science, where we were looking at crystal growth and some fluid science. I'm in front of one of the German facilities here called Tempus, which was an electromagnetic levitating furnace. And we had small samples about the size of a marble that you see here heating up and beginning to glow. And as it's melting, you can see it's oscillating a little bit, and its surface is, you can see the oscillation pattern there. And it's a containerless facility where we can heat samples up and melt them and resolidify them without ever touching the walls. This is another fluids experiment called the Critical Point Facility, and with this we're studying the phase transition between liquid and gas. And this facility operated almost 24 hours a day nonstop for the entire 14-day mission in science back in the lab.
They even let the commander back in the lab once in a while to help.
This is one of our fluids experiments called the Bubble Drop Particle Unit, and here we have a heater near the center of this test cell where we're forming bubbles, just heating up the element there and forming bubbles like you would on your oven at home, but we can do that in a controlled manner and look how they move under different temperature gradients and how they coalesce, how the bubbles form together here. So you'll see a bunch of bubbles just forming and grouping together under microgravity conditions.
This is a French electrophoresis unit. It's one of two electrophoresis units we flew. And we were trying to separate different proteins. And you can see up there where I'm pointing up to the control and display screen. And if you look real close, you can see two peaks. This is the electrophoresis cell where the sample was actually injected and the electrophoretic separation performed.
Well, as you know, we did a lot of repair in flight. I'm spinning this bag around trying to get the air bubbles out. The big problem with a couple of the units we worked on was that bubbles were in places they shouldn't be. So Jim and I worked together to try and purge the Japanese electrophoresis unit of the air. So our first job was to get purged water that didn't have air bubbles in it. So we're very carefully squeezing some out of one bag, sucking it into a syringe. This is the electrophoresis unit, which wasn't really designed to be worked on in space, but in fact we took it out a total of 6 times as we tried to purge all the air bubbles out of it.
This is one of the medical DSOs or experiments that we performed on the flight. This particular one I'm doing, seeing how the eye and head track targets in the absence of using your inner ear. I'm wearing a laser on my head, and you'll see a red dot on the mid-deck lockers there. as I kind of move it between targets and try to acquire them. And sensitive electrodes will measure the electrical impulses to see how my eyes moved, and an accelerometer also on the helmet unit there will measure the accelerations.
During our flight, we exercised quite a bit, and we were very interested in how the exercise perturbed the microgravity environment. And so we carried the microgravity measuring device, which was built right here at Johnson Space Center, and we were able to look at the vibration modes of the cycle ergometer.
Jim's heading on down from the flight deck down to the mid-deck. We showed you the science on board. Now we're going to show you a little bit about living in space for a long period of time. Of course, the mid-decks are our living quarters. It's where we sleep and eat. You can see our sleep station here.
They really woke me up for this picture.
Yeah, this wasn't staged. We got one at Jim that's a little staged, but we really woke Rick up this day.
I quickly caught on, however. Every morning, like I do at home, I wanted to read the morning news, so this is how we get our morning news in space. It comes out of the TIPS machine. Fantastic machine. It really worked great, but you can see the kind of updates we got. A little bit of that is news, and the rest is changes to what we were going to do each day. Well, you enjoy your food up there. It's good food.
This was Carl's one task on board, and I've never seen anybody do it better, was keep track of all our consumables, and he's making sure everything's right.
We carried the rinseless body baths and shampoo to keep ourselves clean, and they worked surprisingly well. We were able to clean ourselves up real well. It's the same baths and shampoos that hospitals use in their intensive care units.
Nobody wants to live with somebody that hasn't cleaned up in 15 days.
I mentioned exercise. Here's a shot of me exercising. We had some very strong cords that isolated the ergometer from the floor to help damp oscillations.
I had a great opportunity to talk with the Japanese student using amateur the ham radio, and it was fantastic. And the people in my hometown were so excited.
This shows our PATM operations where we have an opportunity to send messages home. As you can imagine, it, being away from home for 15 days, you get a little homesick, just like going to summer camp, and that was always a great thing to get messages from home.
We were fortunate enough to be airborne for the anniversary of Apollo 11's launch and the first steps of humans on the moon. And so we had a presentation at the time of those first steps there.
Jim mentioned in that still photo the importance of keeping the windows clean. Jim got so carried away, he was keeping everything really clean.
That's a great shot.
That's great.
But it really was important. The Cape gave us a fantastic vehicle, and we wanted to deliver it back to them as clean as they gave it to us. And as I said before, we couldn't have got all those great pictures without having clean windows to shoot them out of. Here's Jim getting ready to take some of those pictures while I was talking on Sarex in the background.
I'd like to give a tribute to all of our trainers. In this case, the photography training people were able to take somebody who had never really taken pictures before, and we were able to return something useful back to the experimenters here.
This is Australia, Shark Bay, and then looking toward the upper left portion of the screen, the whole the west coast of Australia there down to Perth. Just a beautiful view. And this is the Coburg Peninsula in the Northern Territories of Australia. There's a wildlife preserve attached to it, and just a tremendous view. Australia sort of looks like Mars. It has a reddish tinge to it as you fly over it.
Here's another shot, this time from the video camera that Bob set up of Hurricane Amelia. I told you how I was exercising on the ergometer, and this came into the field of view. At that point in time, Bob was talking to a school in Sarex, and I think by the expression on my face, he knew something very special was happening outside. So while he was simultaneously talking on the ham radio, he fired up the video camera, and we were able to get these shots.
It really was an awesome hurricane.
This is a very special shot. I really enjoy this one. We're going over Central South America, and you're going to see some very special things happen. Up here, you're going to see thunderstorms, lightning at night. These are city lights. Now, I want you to look right here, and you're going to see something. Right there was a meteorite entering the Earth's atmosphere. You're going to see another one right up here, right there. And we got the opportunity, all of us, during the course of the flight, to just happen to be looking out the window at the right time to see a meteor entering the Earth's atmosphere from above. And I think that's a very special memory. Here's our tribute to the people of the Cape. Months before we launched, they told us to the second when we were going to launch. They gave us a perfect vehicle. And right here you can see the Cape. That should be the shuttle landing runway right there. The vertical assembly building right there. The crawlway going out to the two pads, our pad being that one right there. I was amazed at the level of detail you could see just with the human eye.
Unfortunately, all good space flights have to come to an end, and here Jim and I are finally getting to do some pilot stuff. We're doing the flight control system checkout the day before our first entry attempt. Jim is using Pilot here. It's a little portable computer we had on board, actually a workstation that actually has actual orbiter software in it that he can practice landings on. Unfortunately, this is as close as Jim got to landing the space shuttle. But when you're up there for a long period of time, it gives you a chance to look at the displays and get your mind set on landing again, what you need to look at and what you need to prepare for a landing. So this was Jim's one view of landing, and we're going to give you another one here pretty soon.
And this is the end of the Space Lab portion of the flight. I'm shutting down Don and I spent the day shutting the facilities down, and now we're just turning out the last bits of light and closing up the hatch, closing out the tunnel part that goes out to Space Lab.
This is just after entry interface. You can see the pink glow out the windows. Rick said wave at him. He's got a handheld camera. The flashing that you see is from the energized plasma in the overhead windows, the light reflecting off our suits and helmets. And Rick's got the camera, and that's what it looked like out the overhead window. It's just awesome. That's not the tail of the orbiter. The whole reentry was at night, and it was just a bright pink glow. You can't quite see it here, but there's little sparks flying by as pieces of the orbiter are heating up and coming off, little small pieces. Here,
very small.
Really small.
Here we are coming on, turning on to the heading alignment cone, getting ready to land at Kennedy. And the space shuttle is just an absolutely fantastic machine. It launches like a rocket, flies like a rocket ship. You can turn it into a space station, and it flies like a super airplane. Here's a little subsonic aero maneuver we did, a little flight test to document the flying qualities of the vehicle, get some aerodynamic data. You can see the VAB out the window there. Transitioning from the 18-degree outer glide slope at 300 knots to our 1.5-degree inner glide slope. We were trying to touch down at 200 knots, about 2,900 feet down the runway. Here we are pulling out about 1,800 feet above the ground. And
don't miss this. This is my big moment.
300 feet above the ground, Jim.
That was it.
Jim lowered the gear.
Jim did a great job on that.
That's career limiting if he doesn't get those down. I'm going to recommend he gets to fly again. And here we are coming in, touching down at runway 33 at KSC. And you're going to see the chute come out here in a minute.
Bob said he was supposed to touch down at 200. It was, what, 199.2?
Yeah, I missed by a little less than a knot. The drag chute is just an extremely effective deceleration device. It really slows the vehicle down. I did hardly any braking at all. Jim deployed it at 178 knots. We derotated at 175, and then at 60 knots he jettisoned it. And here's a nice wheel stop shot. Columbia's home, and it was the end of an extremely rewarding and successful mission.